Let's take a look at a few operations you can perform on data frames that are either RDD-like or result in creating an RDD. Now, the methods you see here are methods that look very familiar. They're from the RDD API. They're repartition and coalesce, which change the number of partitions that a data frame is split into, and persist, cache, and unpersist, which are really, if you will, three sides of the same coin. They determine the way a data frame is going to be persisted. These are just like their equivalents in the RDD world. So if you want to go back and take a look at RDD persistence, the semantics of these methods are going to look exactly the same. Shorthand really here is that cache will persist the data frame to memory. It'll keep it around in memory. And unpersist will undo the operation of the cache method. If you have a data frame and you want to convert it to an RDD for any reason, because there's some operations using the RDD API that you'd rather use, you can do that. The map method on the data frame object produces an RDD. Every row in the data frame is going to result in a single element being produced in the resulting RDD. FlatMap, just like its cousin in the RDD API proper, is going to take a single row from the data frame and produce potentially many elements, one or more elements, in the resulting RDD. The RDD method is going to convert the source data frame one-to-one into an RDD of rows. The toJSON method is going to do that same thing, except instead of row objects in the resulting RDD, it's going to create JSON strings. So each element in the resulting RDD will be represented in JSON. Some simple data frame actions. And there's collect, which is going to gather up all of the rows in the data frame and return them to the application or the Spark shell as an array. So if you've got a lot of results, maybe you don't want to call collect, but if you know it's a small result set, that's perfectly fine to do. Count, it's just going to count them. First or head is super handy for grabbing the first element, great for hacking, and sometimes it's the thing you want to do. You want to grab the first row in the collection. Take is sort of the big brother to first. That's going to allow you to get the first n rows from the data frame. Show is kind of the human readable version of that. It's going to let you grab the first n rows out of the data frame and display them in tabular form. It actually returns a string. So if you're using this from the Spark shell, it's a very, very nice hacking or debugging kind of method. For each is just like the equivalent in the RDD. We pass it a function, and it's going to execute that function on each row in the data frame. Now, the return value of for each is not the important thing here. It is an action, and it is going to trigger computation, but we're expecting that function that we pass in to cause some kind of side effect outside of the function, like updating an accumulator variable or doing something to interact with an external system. And just one quick example here, another simple query using the SQL method. We'll pass in the string literal CQL query, and then with the results of that, which is a data frame, we're going to call the coalesce method, which is we know this is a pretty small result set, and we only want it to be in one partition. We want it to be on one node. The overhead of trying to split up work on more than one node isn't worth it. Let's just put it all in one place. Then we'll cache it, so that will be persisted in memory. At that point, I can do two actions on that coalesced cached data frame, which is what I do. I call count, I get the total number of elements in it, and then I show the first four. See, if I hadn't cached it, then both of those actions would trigger all the same computations twice to produce the data frame that they're called on. So since it's cached, we're in better shape. This is a more efficient, trivial Spark application. And we see the results that we get, a total count of 54 and the first four rows of the data. So that's just a quick idea of a few actions that we can perform on data frames, a little bit of means of converting data frames back to RDDs, should we ever need to. You can see again here, the API is not super complex. We can really begin to do some meaningful things with just a little bit of knowledge.